Best behavior, guys.
Alright, so today we're looking at handout 1. We're going to start looking at parts of a circle. So how are the parts of a circle related? A circle has many specific parts, including the radius, diameter, and circumference. So we've got to identify what these parts are on a circle and memorize those parts. So a radius is halfway across a circle. The diameter is all the way across the center of the circle. And then circumference is around the circle. It's basically perimeter. So usually you're dealing with perimeter, you think of rectangles and squares and triangles, and you just add the sides. But you can't do that with a circle because it's round. So we have to use a special formula for what we're going to learn today, so we can find that perimeter of a circle. Questions so far? Okay, so the radius and diameter has to go through the center of the circle, so that's the widest part of a circle. Obviously, I could take a line and put it anywhere else across the circle, but that's not the widest part. And so it has to go through the center on a radius and a diameter. Determine the ratio of the circumference of a circle to its diameter. So circumference, again, that's like perimeter. And diameter is all the way across. So we're talking about ratios. So ratios was one of the first things we learned. Do you see anything in this table that looks familiar to you?
The X, Y, you know when you take that, the circumference
The
side
circumference, yeah.
and the diameter side.
Okay, Justice?
The X and the Y.
The X and the Y. And so I think that's what she's trying to get to, is that we're going to find the ratio. We're going to do Y divided by X. Well, does anybody remember what that's called?
K.
K. What's the formal name for it? So we use the variable K.
Constant proportionality.
Constant proportionality. So we're going to see if there's a constant proportionality between the circumference and the diameter. So in this chart, which one is X and which one is Y?
The C where is Y and the diameter is X.
Very good. And so it's always X comes first, then the Y. And so what we're going to do is you're going to go into your calculator now. You need to put in 6.28 divided by 2, and then write that down. And then continue that for that table. When you finish the table, stand up. Okay, on the count of 3, tell me what you got. 1, 2, 3.
3.14.
3.14. 3.14.
3.1.
Okay, the ratio between the circumference and the diameter is represented by this symbol, which is called pi. Good. And it's approximated to 3.14. So pi is an irrational number. It continues on forever. In fact, my high school algebra teacher, she had a poster in her room. It started in one corner of the room and it literally went around the entire classroom because that number just keeps on going. And so we changed that to 3.14 in most situations so that it's a usable number. So that's where they get 3.14, which is something you use when you're doing calculations for circles all the time. So if you're doing the area of a circle or circumference of a circle, you're going to use this value of 3.14. Okay, so there are two circumference formulas. What do you notice the difference between these two? One has a 2 in front, the other one doesn't. What else is different?
They got 2 different variables.
2 different variables. One is R. What do you think that stands for?
Radius.
Radius. What do you think the D stands for?
Diameter.
Diameter. Remember that radius is halfway across the circle. That's why we need 2 of them. Diameter is all the way across. That's why we don't have a 2 in that one. And so you get to choose which one you want to use every time you approach a problem. I prefer to use this one. And the reason I choose to use that one is because when you're doing area, you're going to use radius. And so why not just use radius every time? To me, it's easier to remember 2 pi r than it is pi d. But that's totally up to you and what you want to memorize, okay? So we're going to use the formulas below to find the circumference. Remember circumference. That's like if we took a circle and we put a piece of yarn around it, and then we took the yarn and stretched it out and we measured it with a ruler. So it's how long, if you will, a circle is. It's perimeter. So on this one, are we given the radius or the diameter?
The radius.
This one we're given the radius. So which formula do you think we should use? The first one or the second one? The first one. So in the formula place, put 2 pi r. Alright, now we're going to plug in the numbers. So the number we have to plug in is
6.
r, which is 6. And so 2 times pi times 6. Now instead of pushing our pi button on our calculator, we are actually going to put 3.14. So just remember. Okay. Stand up when you've got it. So 2 times 3.14 times 6. Okay, have a seat. Who wants to share? Anybody? What'd you get?
I forgot the word.
Oh, somebody else wrote it down. Alright, Dakota.
I got 37.68.
37.68 inches. Very good. So on this one, remember, it's like you took a piece of yarn, put it around the circle, and then stretched it out and measured it. So the unit is standard. So whether it's inches, centimeters, feet, there's no 2 or exponent 3 or anything like that. It's just the basic unit. That's what circumference has, basic units. Circle number 2. Are we given the radius or the diameter?
Diameter.
We're given the diameter. And so we can use either one. We could split the diameter and get the radius, or we could just use the diameter formula. So we're going to use the diameter formula on this one. So pi times d. We're going to plug in our numbers. So pi times 14. Calculate. And write it down.
So you did
3.14 times 4. Just raise your hand at me when you got it, so I know. Good, thanks. Thank you.
Pi looks like one of those Chinese eggs.
It does, thank you. Good. Okay, so what did we get?
43.96 centimeters.
There you go, don't forget your unit. Alright, number 3. Are we given radius or diameter?
Radius.
So which one are we going to use?
C.
We're going to use the first one or the second one? The first one. So 2 pi r.
Does it matter which formula we use?
It does not. You use the one that sticks in your head the best. Just make sure that you're using radius when it's radius, and make sure you convert it over if you're switching back and forth. So 2 times 3.14 times 3.5. Give me a thumbs up when you got it. Okay. Thank you. Alright, what'd we get?
21.48 meters.
Okay, so remember, circumference is the outside measure. It's like we took yarn, stretched it out, and measured it, okay? Let's go on to, let's do this. So, the formula for the area of a circle can be derived by splitting the circle into smaller segments. So if we were doing Eureka Math, we'd be doing a project right now instead of a lesson. We would be taking a circle, we'd be drawing a circle, so I'd have to teach you how to use a compass. We'd draw an appropriate circle, we would cut it like this, and we would see how we get the formula for the area of a circle. So what shape is that? This one right here.
Triangles.
No, all together. Pretend the triangles aren't split up.
Rectangular.
It's a, hang on, yeah.
Not a rhombus.
No, it's, I know it.
Trapezoid.
Not a trapezoid.
Coleman?
It's a rectangle.
No, I mean,
That's
you're
the
so
only
close.
shape
You're
I
so
know.
close.
Square.
Evan?
Scaling.
We're not talking about triangles.
Square.
Alexia.
Kind of looks like a parallelogram.
It is a parallelogram, yes. So, notice that these sides are tilted, but they're parallel to each other. Those lines, if they were continued, they would not intersect. And then this is also like that. So, here's the thing. We don't know this yet because we haven't studied it yet, but a parallelogram, to get the area, is just base times height, which is like a rectangle, length times width. And so, what is the length? What part of the circle is that? Is it all of the circle?
Wait, this is like the
So just this part right here, this half right here. If we took our circle, we cut it up, we laid it like that. What is that? Is it the outside of the circle or the inside?
Outside.
It's the outside. How much of the outside?
Half of it.
It's half of the outside. And we said that the outside of the circle is called what? Circumference. And so this is half of the circumference. And so if we start to write a formula, we could say, well, half of the circumference times what? Well, what is this? Inside the circle, what is that? The radius. Good. And so when we create this formula over here, we could say, well, that's half the circumference times the radius. Well, what is the formula for circumference?
2 times pi times r.
2 times pi times r. So I could say, well, half of 2 times pi times r. Well, what is half of 2?
I'm at 1.
So 1 pi, 1 times pi would be pi. And then we would have to do this one. That would become r squared.
Why does it become r squared?
Good question. Because we have to multiply this times something else. What's missing on this? So we took the C, we replaced it with the formula. But what did we not bring down?
The R.
And so now it's R times R. The R squared. So when it took this, put them together. Area is the surface measurement. Of a two-dimensional figure. So two-dimensional just means you could draw it on paper. So it's flat. It's got two dimensions, length, width. It doesn't have height. So surface measure. When we look at the floor right here, we can see our tiles, right? These tiles are 1 foot by 1 foot. And so we could go around and count all the tiles, add the little pieces of tile together that are around the edges, and see how many total tiles we have. That would be the area of the floor in this room. So when we're trying to find area of a shape, it is literally squares represented in whatever unit they're measuring. So if they're measuring in centimeters, it's a little 1 centimeter by 1 centimeter square. If we're trying to figure out how many we could put in there. Here's our area formula. We just derived it up here by looking at that parallelogram. So area of a circle is pi times r squared. So we've got to know our radius. That's why when I'm trying to find circumference, I prefer to use that formula for circumference because you've got the same things. You've got a 2, you've got a pi, you've got an r. The difference in circumference is that the 2 comes in front, and it's just something we're multiplying. In the area formula, the 2 comes as an exponent of the radius. So I prefer to use that one instead of the diameter circumference formula. So circle number 1, we could sit there and count all those boxes and kind of piece together the pieces that are around the edges of the circle, or we could use a formula which would be more accurate. So here's the formula, pi r squared. We're going to plug in the numbers. So here they're giving us the radius. So I'm going to say pi times 3 squared. So I want to teach you how to do that on your calculator. So pick your calculator up, make sure it's clear. Everybody type in 3.14 times 3. Now, up above the 9, do you see something that looks like a rooftop? That's called a carrot top. I want you to hit the carrot top and hit a 2. Now hit equals. What'd you get? 28.26. Show your friend. Make sure if you had trouble putting it in there, there's probably just one little trick that they didn't get, and maybe you can help each other out. Somebody check in with Isaac and see if he knows what he's doing.
That's a parenthesis.
Do you know how to go?
Yeah.
That house spot right there.
Oh, I just jumped into her.
No, look. Okay. You got it. 3.14 times 3. I think you just are. You don't get all of this. No. They put inches.
Inches squared. Anybody need me to help with the calculator? Okay, so something I want to mention, it should be inches squared because we're looking at squares of inches. So literally a 1 inch by 1 inch square. How many of those could we fit into this particular circle? 28.26. So 28 whole squares and a portion of another one. That's how many we could fit into that shape. Looking at circle 2. Notice that we were given 10 centimeters. Is that radius or diameter? What? That's the diameter. If it's all the way across, it's diameter. So diameter is 10, so what's the radius? 5. Half of it. Remember, radius is half. So formula again, pi r squared. So pi times 5 squared. So we're going to put that in our calculator. 3.14 times 5 caret top 2 equals. What'd you get?
78 squared.
So 78.5 centimeters squared. You try the next one on your own. Try the next one on your own. Write down the formula, plug in your numbers, and then put in your calculator. If you're ready, raise your hand.
Ooh, ouch.
6 caret top. Square up your centimeters. Good. Same thing. She didn't do something right, so you can figure it out. Alright, so it looks like most of you got it. And so I'm not going to tell the people watching the video what it's supposed to be. They're going to figure it out on their own. And then come check with me. See if they got it right. So, the difference between the area and the circumference of a circle. Who wants to stand up and tell me the difference between circumference and area? Not Alexia, because we all know she can do it. I want somebody else. Just as good.
Area is all the sides added up, but circumference is circles, so there's only like one side, and it describes the length, the one length of a circle. Just
Okay, so I agree with part of that. Does anybody agree with part of that?
explain things.
You tried. Alexia?
Area is the inside of the circle, which is kind of these squares you can usually fit into the inside of it, and circumference is kind of like the perimeter of the circle. It's just the whole outside whole out of view.
Okay, so turn to your neighbor, tell your neighbor what area of a circle means and what circumference means in your own